So we're gonna have a single replacement reaction here, and we're reacting iron, and it's gonna be reacting with hydrobromic acid. And I want the products in the states, and obviously balancing if that's necessary. So I'll put iron. Let's pick a pen. Put. Why is it doing that? Don't save that. Let's try that again. No, not that. 18. Editing. Zoom that. There. So, iron? And why are we putting solid? Because it's a solid at room temp, yep. And then what's hydrobromic acid look like? State? Aqueous. Single replacement reaction, so what's going to get swapped out? Why do you know the H is the thing that's going to be moved out, not the Br? Because it's the cation, right? In the hydrobromic acid, the cation is the hydrogen, and your options for iron are it's got zero charge or it's got to have a positive charge, right? So I couldn't swap the bromine out because then I'd have two positives bounded together, which is not possible. So we'll end up with an iron and a bromine and a hydrogen. And what's wrong with that? It's a diatomic. What else is wrong? What else is wrong? Anything else? No? The iron and the bromine aren't balanced. If you look on the table, the iron has an oxidation state of 2 or 3, not a 1. So which one would you pick, the 2 or the 3? Why 2? No, so what if it's a positive 3 and you need 3 of them? What one would you pick? There's a 2, a 3, and a 6 on the table, but one of those looks a little different. No, not underlined, but you're on the right track. They're all black. Bold. So the 3 is bold. So that means that's the oxidation state it's going to undertake under normal circumstances. To get it to be iron 2 or iron 6, you have to do something interesting to the temperature or the pressure or a catalyst or something like that. So if it's just going to react under normal circumstances, it's going to be 3, which is why iron in the form of oxide, in form of rust, is iron 3 oxide. Normal rust is iron 3 oxide because that's what normally happens to iron. So then I'd want to put a 3 down here for the bromine. That way I could cancel out the charges. And this guy would stay aqueous because bromines are aqueous, and then this guy here is a gas because it's hydrogen gas. And then balancing this out, slightly more complicated because it looks like I'm going to need a 3 here, but if I put a 3 here, then that'll have an odd number. So if I put a 2 here and a 6 here, then I can put a 3 there and a 2 there. Are we okay with that? I guess as most of you probably didn't do iron 3 bromide, if any of you at all did. Okay, so we're going to, if we're starting with 125 grams of iron and 175 grams of hydrobromic acid, what would be left in the container? All right, so that's what we're looking at here. So how do you approach these problems? What do you do first? Huh? Like overall, what are we going to be doing here? It's a limiting reagent problem, right? So what do you do to figure out what the limiting reagent is? You take each one of your reactants and do what? For each one of them, or just one of them? Just one. So you take both of your reactants and those values, and then you calculate out how much you can make of one of the products. And then whichever one's smaller, now you know which one is your limiting reagent, and then you calculate your limiting reagent to the other products. So in this case, we're going to need to do 3 railroad tracks and some subtraction, and that's it. So let's go ahead and run through that. So we'll start off with 125 grams of iron. And iron is 55.847 grams for 1 mole of iron. And then in this problem, for every 2 moles of iron, let's go to hydrogen because it's easier. 3 moles of hydrogen. And then for every 1 mole of hydrogen, it's 2.0159 grams of hydrogen. Where did the 2 and the 3 come from? Those are the coefficients in the balanced chemical equation. So we have to use those. 8, 4, 7, 8. Times 3 divided by 2 times 2.159 equals. So I'm getting 7.25 grams of hydrogen gas. Okay. So now let's go ahead and do the other one. So I've got 275 grams of hydrobromic acid. 1 mole HBr, grams of HBr. So it's 1.00795 plus 79.904. So that'll give me 80.912. And it's 6 moles of HBr and 3 moles of H2. And for every 1 mole of H2, it's 2.0159 grams of H2. All right, so I've got 275 divided by the 80 divided by 2 times 2.0159. I get 3.43 grams of hydrogen. Okay, so which one's my limiting reagent? My hydrobromic acid, right? So the moment that I've made 3.43 grams of hydrogen gas, what happens? The reaction stops. Why does it stop? I have no more acid. It's all gone. I've got lots of iron sitting around, but I have no more acid left. Okay, so at this point we know what's left in the container is 3.43 grams of hydrogen, 0 grams of hydrobromic acid, and now we need to figure the other stuff out, right? So give me what would you like to do next?
Real quick, can I ask you a question?
Of course.
You had done, instead of doing hydrogen, could you have done iron?
Sure.
bromide?
Yeah.
It's the same.
Totally the same.
Just pick whatever one.
Doesn't
You
matter.
just use the same on.
You use the same one for both of them, right? Because if I didn't use the same one for both, then those numbers, apples and oranges kind of deal. Don't know. Okay, so I know that my limiting reagent is my hydrobromic acid, so then all further calculations are done with my hydrobromic acid. So let's do 275 grams of HBr, and then 80.912 grams of HBr, 1 mole HBr. And since it doesn't matter which one we do, let's do the iron one. So for every 6 moles of hydrobromic acid, I only need 2 moles of iron, and then for every 1 mole of iron, it's a massive 55.847 grams of iron. All right, let's punch that out. So
I have 275 divided by 80.9 divided by 3 times 55.574. I get 62.9 grams. Do I have enough information to stop doing railroad tracks and figure out everything? I think I do. So I know that I've got 0 grams here. That's all gone. I know this is my mass of hydrogen, and I need to know the other two pieces. So I definitely have some leftover iron, correct? So my leftover iron, I can figure out how much is left in the container by taking the 125 that I started with and subtracting off the 62.9 that I know I needed. So six. Yep, that's it. So I know that's how much iron is left in the container. Do we understand how I got that? This 62.9 number that I calculated out, what we were saying is if I had 275 grams of my hydrobromic acid, I would need 62.9 grams of iron for them both to run out at the same time. But I started with 125 grams, so then I just subtracted them off, and then I'm saying I've got this much of it left over. So now I know how much iron I've got left over. Now I know how much hydrogen I made. The only thing I need to do is figure out how much my iron 3 bromide. So how do you want to do that? You could do another railroad track, or you could say 125 plus 275. That's 400 grams of starting product. Are we okay with that? What do we know is in the container already? No, there's no hydrobromic acid in the container. Okay, so we know that there's 3.42 grams of hydrogen, right? We know that there's 62.1 grams of iron. What else do we know? And there's 400 total grams of stuff that need to be in the container, right? Okay, so what do we got here? I've got a 2 and a 5 and a 5 and a 6. So that's grams of stuff that's in the container that doesn't have the other product. So if I subtract 400 off of that, what would that be? 34.48. So that's a way to do it. The other way to do it would be what? Yeah, just run another railroad track just like we did here with the iron, except do it for the iron bromide. So if you calculated that out, you should get exactly that 334.48. And we know that this is going to work out for us because here's my hydrogen mass, here's the leftover iron mass, and here's the remaining mass. And these things all add up to what? What I started with. And I've accounted for all of the mass that I put into the container. Okay, let's move on. What are we going to do for balancing this one? So this is basically the same question as the last one. Ten carbons, does that work? What else? 16 HCls? And then an 8Cl? Okay. And what do you think for this one here? Sounds good. For this one? Chlorine? Sounds good. And for the carbon? Sounds good. And the hydrochloric acid? Is there any water? There isn't. All right, so I'm going to start off with 125 grams of my hydrocarbon and 275 grams of my chlorine. Okay, so we'll go with 125 grams C10H16, 1 mole C10H16. Does anybody have a mass for that? One 136.237 grams. And for every 1 mole, let's do 10 moles of carbon. That'll be easier. 1 gram or 1 mole of carbon, and then it's 12.011 grams of carbon. So this will give us our grams of carbon. So I have 110 grams of carbon with the decimal places after it. All right, do the same calculation with chlorine as our starting product. So 275 grams of 35.4546. Is it 546 or 453? 453 times 2. So Cl2. All right, I've got 70.87 grams of Cl2 for every 1 mole of chlorine gas. And then for every 8 moles of chlorine gas, I've got 10 moles of carbon. And for every 1 mole of carbon, it's 12.011 grams of carbon. All right, so I've got 275 divided by the 70 times 10 divided by 8 times 12.011. Oops. All right, so I've got 58.3. So who's my limiting reagent? My chlorine gas is my limiting reagent. Okay, so then we're going to need to calculate out the other. So right now what I know is I have no chlorine gas left in the container, and I have this much carbon in the container. And let's calculate out the others. So I've got 275 grams of chlorine, 70.87 grams of chlorine, 1 mole of chlorine, 8 moles of chlorine, 275 grams of chlorine, 1 mole chlorine, 70.87 grams of chlorine, 8 moles of chlorine. And the hydrochloric acid, 1.0795 plus 35.435, and so that's 16 moles of HCl, and for every 1 mole of HCl, it's 36.4 0.5144 grams of HCl. And then this one down here, we'll have 1 mole C10H16, 1 mole C10H16, and then 136.237 grams C10H16. All right, so 275 divided by my 70.87 divided by 8 times 16 times 36. So 283 grams. And then 136.237. 66.1. No, I got that much of that stuff. I don't have this much of this stuff. I got 125 minus 66.1. 9, 5, 8. So in my container, I've got 58.9 grams of my decane. I've got 58.3 grams of carbon. I've got 283 grams of hydrochloric acid, and I've got no chlorine left. Do we have any questions about that? No?